Okay, so we've actually seen a lot of bits and pieces of this thing. We're now going to put it together and actually take a look at a picture of this graph. So let's start by identifying some of the characteristics that we talked about. Let's start with n behavior. Its leading coefficient is a cubic, which tells me it's going to be in the first and the third quadrants as far as I graph it. Then let's do the y-intercept, which is f of 0, which would be 0 cubed plus 0 squared minus 4 times 0 minus 4, which is negative 4. So I know it crosses the y-axis at negative 4. Let's do the x-intercept. So 0 equals x cubed plus x squared minus 4x minus 4. Factor by grouping seems to be a good trick to use. So that would take out an x squared, which should leave us with x plus 1. And then take out a 4, which will leave us with x plus 1. And then in factored form, we get x squared minus 4 times x plus 1. And then I can keep factoring. That'd be x minus 2, x plus 2, and x plus 1. Which means that it crosses, or the solutions for this equation would be positive 2, negative 2, and negative 1. So it crosses the x-axis 3 times. Let's see, so let's put all this together. Okay, so let me get just a rough sketch here that I could label some information on. Alright, I know that it goes in the first and the third as far as n behavior goes. I know it crosses the y-axis at negative 4. I know it crosses the x-axis at 2, negative 2, and negative 1. Oddly enough, we can still use bounce and wiggle here. None of my roots are repeated. They're all singular cases or linear cases, but that's an odd powered number. So there's one root of 2, one root of negative 2. So that means all of these are wiggles. Okay, so I can go to my graph and I know it wiggles here, and I know it's got a wiggle here, and I know it's got a wiggle there. Okay, so I can come back in and sort of connect all of these pieces. No, it's got to connect through that. Okay, and this is my little disclaimer. This is a rough sketch. Okay, it's not the actual picture, but it's a pretty close approximation. And again, when you get to calculus, you will get more detail on how that works. Okay, number 2. Again, let's start with listing out our common properties. So let's go with n behavior here. It's a cubic again, so we know it's positive, so it goes in the first and the third. Then let's look at y-intercept, which is f of 0. So 0 cubed minus 4 times 0 squared minus 7 times 0 plus 10. And that would put it at crossing at 10. So I know 0, 10, I have a y-intercept there. Got an ordered pair. Okay. Then we're going to go with x-intercept. And I notice that this is not factor by groupable. Okay, so this is where rational roots theorem is going to come in. In that I want to take a look at what are the possible whole numbers that I could try. So I'm looking at the first and last. So with 10, I get 1 and 10 are the factors, or 2 and 5. And then that's my p. The q, which is the first number, has got 1 there. So I know my possible roots are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, or plus or minus 10 over 1. And I'm just going to guess and check which one of those seems to work. So let me make a list of my coefficients. So x cubed, x squared, x and a constant, 1, negative 4, negative 7, and 10. Okay, so I don't know, I was kind of am amused to see how some students attempt to guess and check here. I'm kind of on the, I'm going to try to do the laziest thing possible. So I'm going to start with the smallest numbers and see if those actually work. So I'm going to start with just 1 and see if I can luck into it possibly working here. So try 1, drop it down, so multiply, and then combine like terms, and then multiply. Combine like terms, and then multiply, and I get 0. Yay! Okay, so that meant that my guess was pretty good. So what does this 1 mean? This 1 means, so at x equals 1, so that means x minus 1 is a root. And the other piece would be x squared minus 3x minus 10. And so let's see. We know lots of stuff about quadratics, so that looks pretty factorable. X and x, 5 and 2. 5 needs to be minus and the 2 needs to be plus. Okay, so that's our factored form. And so our roots then would be 1, negative 2, and positive 5. Okay, so let's fill in what we know about our graph. Kind of scroll down and let me get a little fake graph space here. Let's see. I know it crosses at 0, 10. It's going to cross the y-axis. I know end behavior-wise it's going to come up. So it's going to go first and third, so I can fill that in. I know, let's see, I got a couple of intercepts that I can label. Let's see, I know it crosses at negative 2, at positive 1, and at positive 5. And again, all of these are singular linear roots. There's no multiplicities of, there's no double multiplicities or triples, so they're all to the power of 1 or linear. So I know they're all wiggles. So I know it's going to wiggle through here, it's going to wiggle through there, it's going to wiggle through there. And so I can come back in and kind of correct that. So it's going to have some sort of rough sketch that looks about like that. Okay, again, rough sketch. When you get to another unit in calculus, you'll get a lot more detail on this. Okay. Okay. So we're going to end with again something that's relatively not obvious, but I kind of built this one to have a little teeth to it, just to make us think and appreciate some of the concepts we've seen. But I'm going to hold your hand through this one, so that's okay. Let's start with end behavior. So end behavior, we're now looking at a fourth degree, so that means first and second quadrant. The y-intercept, so f of 0, so that would be f of 0 would be 0 to the fourth plus 2 times 0 cubed minus 23 times 0 squared minus 24 times 0 plus 144. All of that to basically say it's going to cross at 144. And that's okay. Don't get freaked out about the big number. That's perfectly fine. So I have a y-intercept there. And then I want to do the x-intercept. So I want to figure out where, let's see, x to the fourth plus 2x cubed. I want to figure out its factors. and hopefully you're like, oh wow, that's a big list. So 144. So a nice little technique to make a factor list is, let's see, 1 and 144. I know 2 goes in there, times 72. 3, let's see, times 48. So I'm just making a list, and then I'll kind of make a little subtle point here at the end if you've not heard this neat little trick. Let's see, if 2 goes in there, I can see 2 times something, so 4's definitely got to go in there, and that'd be 4 times 36. And then 6 times 24. Sorry, 5 doesn't work. There's no 5. 5 didn't go into 144. 6 might, well, if 2 and 3 do, then 6 has to. 2 and 4 do, and 4 and 36. So I see there's no even component, so that would be 8 and 18. And then 9. 9 doesn't. 10 doesn't. 11 doesn't. 12 does, and that'd be 12 and 12. Okay, now I'm actually stopping here, and I'm going to stop because if you notice how I've got these numbers aligned, I started with the smallest, so I went 1, 2, 3, 4, 5, 6, 7, 8. So I went all the way up to 12, and then as soon as I see these two numbers match or get really, really close together, I know I've got all the factors on both sides of this. So it's a nice little trick to do that. Okay, so let me set up my synthetic here. X cubed, x squared, x, and constant. Okay, now for the horrifying realization of how many possible roots do I have to pick from here. I've got 1, 2, 3, 4, 5, 6, 7 times 14 of these things to get plus or minus 1, plus or minus 144. So I literally have tons to pick from. I'm going to give you a huge hint. I'm going to say let's pick 3 because I am trying to illustrate something here. So if this had been just a naked, and then this would be something that I would probably give a college algebra student, because when they're trying to learn this skill, this would definitely force them to learn it. And at calculus level, this is a little on the complicated side because we're probably going to have you spend more time doing other things. But it's, again, I'm holding your hand, and it's nice to see the big picture of how this all works together. Alright, let me collect up the coefficients. 1, 2, negative 23, negative 24, and 144. Alright, so if I put a 3 in there, so drop the 1, multiply gives me 3, add, I get 5, then 15, add that together, gives me negative 8, add that together, and I get, actually multiply that and I get negative 24, which gives me negative 48, which gives me then negative 144, which gives me 0. Okay, and then, so that would translate into x cubed plus 5x squared plus, minus 8x minus 48. I am just going to tell you, try to do 3 again, and you can just set it up just like this, and you'll kind of go, oh, I see why you did that, dude. That, you'll kind of get the big picture here. So if I try 3 again, drop the 1, multiply, that gives me 8, that gives me 24, so that's 16 when I combine like terms, and then I get negative 48, and that gives me 0. Okay, so what I've just shown, I've shown that x minus 3 has a multiplicity, and I'm left with x squared plus 8x plus 16. Okay, and hopefully you recognize this as one of our perfect square trinomials. This factors into x plus 4 squared. Okay, so you can see, I told you I was going to hold your hand. I picked one that had a multiplicity on it just so we could practice using that skill in this, or at least claim that we've seen it. So when I set up my sketch, I know it's got to cross the x-axis at positive 3 and at negative 4. I know it's got end behavior up in the first and the fourth. I also know way up here at 0, 144, it's got to cross the y-axis. I know because both of these are multiplicities of 2 that there bounces off the x-axis. Okay, so I can come in and connect these pieces together. Okay, it kind of looks like a W. And again, this is a rough sketch. I am not sure where it turns around at, even though I have it drawn to turn around at that y-intercept. That's probably not true. It might be close to it, but I just don't have enough information. So when you get to that point in calculus, you go, oh, okay, this is what it was talking about. So there you go.